Okay, so if you go to the class homepage, right, you're going to see that there are a couple of links in there. I have broken down the class into several weeks. There's 6 weeks in the summer semester. And the first thing that I want to go through is the little welcome message, which I sent out to everyone in the class. There's 2 class sections. There's an online class. There's a face-to-face class. I'm assuming you're in the face-to-face class. Attendance, it doesn't really matter to me in which section you're in. I am not going to count your attendance by your physical presence in class, but by the assignments that you turn in. So if you're turning in the assignments, you don't have to worry about coming to class. If you're in the face-to-face section, you can do the class online. If you're in the online section, you can come to the physical class if you need extra help, to do that. So that's it. Just make sure you turn in the assignments. If you fall too far behind, you might get dropped, especially in the first week. Make sure you keep up with these assignments. This is a labor-intensive class. It's kind of like a math class. You have to keep up with the work. The work is cumulative, so whatever you learn today is going to be used on Thursday, etc., etc., etc. If you don't get what we did today, there's definitely no way for you to do the things on Thursday. So it's very important for you to keep up with the work and the assignments. Okay, so the official deadline is, turn it in within a week or 7 days after it was assigned. So if the things were assigned today, you should turn them in by next Tuesday. Okay, and that being said, I'm very lenient as far as turning in things late. So if you turn it in by the end of the semester, I'll give you full credit for it, unless I dropped you, right? So make sure you don't get dropped first, and then if you survive the initial dropping, if you turn it in by the end of the semester, I will take it, I'll grade it for you, okay, with full credit. Now, I offer a regrade, courtesy regrade for any assignment that you turned in. So if you turned it in and it was missing something, there's going to be a feedback that I left in the assignment. You can see it, you can correct the assignment, you can resubmit it, and I'll regrade it for full credit. Okay, so that's that. There's a midterm and a final exam. Those I offer also regrade, but I give you only 50% of the points that you lost back. All right, so let's say you took the midterm, you bombed and you got 50% on it. I will offer you a regrade. I'll explain to you this is what was wrong with the midterm. Then you go and you fix your midterm, you resubmit it, and I'll give you half of the points back. So you're going to go from 50% to 25%, which is a pretty sweet deal. In addition to this, there's extra credit opportunities. So it's pretty easy for you to get an A as long as you keep up with the work. And if you don't, you're going to be in a world of trouble. Okay? The format for your programs, every program should follow the same format. You should have some comments on top of the program. You should have your code in the middle, and then at the bottom of your program, you'll have more comments showing me how the program ran. Okay? And that's it. That's basically the format. If you need to contact me, you can email me. That's my email here. And make sure that you include CSIS 45 in the subject line of your emails, because I teach 30 units plus in the summer, which is like 300 students. And if you don't tell me who you are or which class you're from, I'm going to have a hard time finding what you're asking me about. Okay, so include the CSIS 45 and the assignment number in there. So if you're doing program number 2, tell me I'm doing program number 2. That's where the question is about. Okay, you can also message me here using this little inbox thing. You can click on that and send me messages through the online system here. It's actually pretty good. If you do that, if you're messaging me here, you don't have to include which class you're in. It automatically tells me where you're from. Okay. As far as grading things, your code will be graded heavily on the comments you put in. Right? If you're missing these comments on top, I'm going to take off 30%. If you're missing these comments on the bottom, which show me how the program ran, I'm going to take off 30%. So if you don't want to lose 60% from every possible assignment, follow my format. Okay? And I'm going to be brutally taking points off until you get it right. And trust me, if I take 60% off, you're going to get it right in probably the first couple of assignments. That's the idea. Okay, so that's the logistics. Let's go back to the home page, and if we look at the next thing, there is a syllabus in there. So that should open on a new link, on a new tab. Okay, so this is your syllabus. It's a 3-unit class. It meets from 4 to 5:50 p.m. All right, from the 19th of June to next month, 28th. Okay, grading is the usual. There's a A-, there's a B+, and they're all broken down into little categories based on what tier you get. Normally, actually, if you just get over 90, I'll give you an A. Don't worry about the A- business. And if you're somewhere in between, you know, you could get the B+ and all that other stuff. Okay. Textbooks are not required, but I have found a few good ones that you could, you know, you can find online. And these are the ones. I will be using PowerPoint from this one, the middle one. I think that's the Savage one. Yeah, that's Walter Savage. And maybe some PowerPoints from this one, from this first book. Okay, this other one here is probably the highest rated out of the 3, but it's just for reference. I'm not going to require you to buy a textbook in this class. Everything that you need is going to be posted at this class webpage. Okay, so additional resources. If you click on this little tab here, you can see a bunch of links in here where you can download code blocks, the programming guide, some interactive tutorials. Right, this one right here on the bottom is pretty good. Bucky's tutorials. This guy went in there and made a whole bunch of, you know, C++ tutorials, starting from the very beginning, walking you all the way up to some pretty advanced topics. Okay, I'm also going to make videos of my own. I'm recording this today. I'm going to post it tonight, as soon as I get a chance. And I'm also going to, as I'm writing the programs, I'm taking notes for you, so don't worry about, oh, I can't keep up with this guy, he's going too fast. I'm your note taker, right? I'll post the notes as I type them on the class webpage, and next to them there's going to be a video too. Okay? So that's that. We'll go over all these little things as, you know, as when we get to them. Okay? So those are the resources, and again, there's a link in there for you to download code blocks. So first of all, on all these computers here, code blocks should have been installed, but it wasn't. So if you really want to, go to, while I'm talking, Google code blocks, right? And then you're going to go to the code blocks webpage. Okay, then you're going to click on downloads, right? You're going to download the binary release, and you're going to get this one right here, the MinGW setup, right? So you can get it from sourceforge.net. So click that link, download the file, install it, so that you can, you know, write your programs today. Okay? So that's what you need for this class. Code blocks is for Windows, and you know, these computers are Windows. That's why I'm telling you to download this. There's other tools for you to write your code, and I could either run a virtual machine and then write the code in Windows, or I can use another one of those tools that you can use, and what I'm going to be using is CLion right here. Okay, it's a little more advanced tool than what you need. You have to create a project, and then from that project you have to make a file and all that good stuff. So for simplicity's sake, I recommend using code blocks. Okay, it might not look as pretty as this thing, and by the way, you can also get this yourself. All of you, since you're registered in this class, you have a Gavilan email that ends with a .edu. With that email, you can go and Google JetBrains Education or student. JetBrains student. Okay, the JetBrains student, you click on this. And these guys are pretty awesome. They make some really, really good tools. Like if you want to write Java, if you want to write Python, if you want to do PHP, they got the tools for that. And all these tools cost a lot of money, right? And they will give them to you for free for 1 year as long as you're a student, right? So you go in there, you tell them I'm a student, give them your name, give them your email, click the little button, and they're going to send you a link. You click to confirm the link. Then after you confirm the link, they send you the license code, and then you can use that license code to register this and use it. Okay? So if you want to get fancy and use this at home, be my guest. Okay? But you don't have to. Okay? For what we're going to do, you really don't have to do this. Okay? But I'm going to be using it. Okay? So those are the tools. And now let me jump to the week 1. Okay, so this is week 1, right? We're on Tuesday, and what I'm going to do is I'm going to cover comments, input, output, and variables, and there's going to be a few assignments that go with that, right? Yeah, I think I'm going to cover maybe input also. Okay, so let me go through some of these things. So compile and run a program in code blocks. There's a video that shows you how to write a program. I'm going to show, you can watch that if you're in the online class. And and there's also some explanation of what's input, output processing and all that stuff. Again, that's going to be part of this video today. There's a C++ programming guide. Let's have a look at it real quick. All right. There's a whole bunch of stuff in there. I'm not even going to read it to you. We'll go through this as we go through things. Okay, so the first thing that's after that is comments. Right? Comments are how you document your code. Right? So if you write stuff in code blocks, by the way, this is a picture of code blocks. That's what it looks like. Once you install it and you look at it, that's what it will look like. When you write comments, right? Well, actually, let me just get this thing started so you know what's what. Okay, so first of all, the tradition in programming is for you to start with a little hello world, right? So the first 2 things that we need to do for every program is to put these first two lines on top, right? Include IOStream, using namespace std are going to be required so that my program works. Okay, so that things like the cout right here work and do things. Okay, so if I go in there and I just hit the little run button, right? Ooh, I hope that works. That run. There you go. So it shows you the little message on the bottom, hello world. So if you run this in code blocks, the little command line is going to open up in Windows. It'll be like a little black screen and you'll stay in there. But this thing is a little fancier, so it lets you show the output right there on the bottom. Okay? So first of all, this is an example of output, right? What is output? Output is some information that shows on the screen that comes out of the program. Okay? If I get rid of this line right here, this format right here will be the format for every one of your programs. You're going to have your include IOStream. You're going to have using namespace std. You're going to have an int main, which is basically the main place where the program starts. Okay, if you don't have these things, programs are not going to work. You might be able to get rid of one of these here. Let me try that. All right, if I run this, yeah, it still works. Some compilers will give you an error message. It'll tell you, oh, this thing has to return something, but I'll just delete it for now. White clutter things. Okay? So right now the program doesn't show anything. Right away, this message right here, process finished with exit code 0, will also show up in the little window that code blocks will open when you run the program. Okay? All right, so let's bring this back in. Cout hello world. Right, and let me just even get rid of this last piece right here, run it again. So there you go, hello world, and then process finished with exit code 0. Okay, so this here is an example of output. Okay, output is information that comes out of the program. Let me move this. Okay, so and if I run my program again now, by the way, notice I put 2 forward slashes and then I typed a bunch of stuff in here. If I run my program, notice this is how it used to be before. If I run it, it doesn't change at all. Okay, so what does that tell you? That tells you that this has no effect on the program itself. Okay, So I guess I should tell you that, first of all, what's a comment? Comment is explanation or documentation for your code, right? What is the actual code? Well, this is the code. These different things here that we started with in the beginning, that's the actual code. The code are the programming instructions, okay? So the simplest programming instruction where you start most programs in any programming language is first you try to see if it works, right? The basic thing you want to do is try to show some message. So how we show a message in C++ is using cout and then less than. Okay, that's just the syntax of the language. That's the rule of this language that we have to follow. Just like the English language has rules, you have to use commas, you have to start sentences with an uppercase, maybe you have to end them with a period or an exclamation or whatever. C++ also has a syntax, right? What is the syntax? Most of the lines, most of the programming instructions, not all of them, and you'll learn which one's what, end with a semicolon. So if I got rid of the semicolon here and I try to run the program, it's going to give me an error message. Okay, this is the kind of an error message that you were going to get in code blocks. Okay, so it's telling you, oh, something, something. It's expecting semicolon after the expression, and then it actually points to where that thing is. If you write your code in CLion, which is what I'm using, this is CLion, it would even highlight the things for you. It's basically like writing your paper in Word, right? Word is going to highlight the syntax violations and, you know, kind of guide you through the process. Okay, so if I add a semicolon, right, there's no underline here. If I run the program again, right, hello world, it works. Okay, so some other things that I could break are maybe I messed up this and I put it the other way, right? That's also not good. Notice how it highlights the whole thing, but I'm going to try to run it anyway. There you go, a bunch of errors. Invalid operand, blah, blah, blah. Some of these messages are very cryptic. C++ is not a user-friendly language. Okay, some other programming languages like Java and Python will give you much more meaningful error messages. C++ doesn't. A lot of times, things are just not going to work at all. You might even have an error and the program is going to run and it's going to crash or not work the way it's supposed to. That's the nature of C++. Okay, it's a very old language. They didn't care about making it user-friendly back in the day. That's what it is. Okay. So how do we do output in C++? We do cout less than, right? So let me put a little comment in there. So this is how we do output in C++, right? And whatever's out after that is in quotes. Anything in quotes is called a string. Okay? So this here, this piece, all the way to there, that's called a string. So string is anything in quotes. Okay? And so comments, what else about comments? Every one of your programs, remember I told you that you should have comments on top of the program, comments on the bottom of the program. Okay? What are the comments on top of the program? If you look at the class page, I tell you right here. So you should have your program name, the date, and maybe an algorithm. Okay? And I'll tell you what an algorithm is in a second. Alright? So 2 /. Alright, this is going to be my first program. I'm just going to call it P0, CPP. Okay? And the date, let's change this to date started and date finished. Alright, if it took you multiple days to get this done, you know, put separate dates. If you did it on the same day, put 1 day. So this is 0620. Okay, put your name in there. That's my name. Okay, and the description. The description is describe what the program is supposed to do. Okay, most of the times these descriptions you can just go to the class webpage and the assignment itself, highlight everything in what I tell you to do, copy it, paste it in there. Okay, so this is describe what the program is supposed to do. You can copy paste this from the assignment. Okay? So at the very least, these are the things that every program should have. So every one of your programs should have the following 4 lines of comments. Okay, let me make this a little smaller. Okay, too small. Okay, so these are the lines that you have to have, right? These are the 4 lines. Every program should have this. Okay, what else are you supposed to do in your program? Include how the program is running. That tells me that the program is running and it's not just giving you a bunch of error messages. It shows me that you tested it, which is very important, right? So you're just going to go in there, copy this text, whether you copy it from here or from CppLecture06202017 little dialog box. Either way works. And I'm going to put this right underneath my code using multi-line comments. Okay, so a multi-line comment starts with /* and it ends with */. Okay, and then that allows you to not have to go in there and put 2 // in front of every line that you want to have as a comment. So I'll just paste this stuff in there. I guess you can erase that first line if you want. Doesn't really matter. So this is your sample test run. Okay, so also known as tests, right? So yeah, just test. Okay, so if you don't do this, I'm just going to assume your program doesn't work and I'm going to take off 30 points. You might get a little message. In the beginning, I'll tell you, well, you forgot to include the comments on the bottom. But if you continue to not do that, I'm just going to, there's going to be like a little feedback, untested, and you lost 30% of your grade. Okay, so very easy. Put this at the bottom of every program. Also, if your program has any kind of an error, like this kind of stuff, for example, right, and you ran it and it doesn't, right, it doesn't do anything, or it gives you some weird message and you can't figure out what it is, then tell me. Instead of trying to sit there and explain to me with your own words what it's supposed to, like what the error message was, copy that thing, paste it in there, email it to me. Okay? It's much easier for me to troubleshoot your programs without having to run them for you. Okay? So that's the name of the game. That's how we're going to do things. Okay? So comments on top, comments on the bottom. Comments are very important to document your code so that other people can understand what your code is doing. As far as the program itself, the comments are meaningless. The compiler, which is the program that translates this code into a machine language, doesn't care how many comments you have, right? So you can get rid of all of them, it'll still work the same, or you can add a whole bunch, it'll still work the same. Okay? In the beginning of this class, you should write a whole bunch of comments, just like I'm writing them for you here, and it will help you understand what you did later. I don't expect you to memorize things. I don't memorize syntax. I mean, I've memorized some of this stuff because I've done it a million times, but it's not important. If I told you, all right, go pick up PHP and learn PHP, it's just another programming language. It's going to have very similar rules to this. Some of them might be different, but the fundamentals are going to be the same. Okay? Bless you. Twice. Okay, so comments, any questions about this stuff so far? Yes, sir?
Why only a single slash for the comments at the bottom of the page?
This one here?
Yeah.
Okay, why only a single slash? Because this is a multi-line comment. A multi-line comment is anything that starts with / asterisk and it ends with asterisk /, right? So that allows me to put a bunch of things in between these. So in between this and this, all these lines right here are considered comments. So if I run the program again, it runs just like before. So this does not have any effects. Okay, so these are multi-line comments. Okay? Any other questions? All right, good. So the next thing is, and I tell you here, oh, by the way, if you look at here, this is CppLecture062020. When you run your program in CppLecture062020, it's going to open up a little window like this. Depending on what Windows you have, since most people are now on Windows 10, you can just drag the cursor in there to select the things. that you want to select, and you just hit the enter to copy. On other Windows, on like Windows 7, you have to click on this little part of the screen right here. Then it'll pop up with a little drop-down menu. You click Edit, select all, and then you can select the same way as you would in Windows 10. Okay, if you need help with that, let me know. So these are the comments. Now let's go back to the home page and week 1. And the next thing I want to do is, so yeah, grading rubric is you're gonna be graded on the comments on top, comments on the bottom. Some other things, I'll talk to you about them later. Okay. Before I get into more programming, I'll tell you a little bit about the basic terminology, what is what. All right. So if I go to this is one of the PowerPoints from that Savage textbook. And it might have a whole bunch of pages in there. I'm not going to even go through this. You can read them on your own. Okay. So I'll give you my summary of this. There's the next one, programs, languages, compile, interpret. That's my more condensed version of that other one. And let me just go through it real quick. Okay, so first of all, there's all kinds of different programming languages. There's high-level programming languages. There's low-level programming languages. At the lowest level is machine language, right? The machine language is just a bunch of ones and zeros. You're basically just telling it to turn off or on a particular piece of circuitry. Okay, so it's either electricity is flowing through it and it's on, or it doesn't and it's off. And we choose to represent that as ones and zeros. Okay, when you compile your C++ programs, the final thing that you're going to get is an executable file. Okay, I can't really see that in CLion, but if you actually do this in code blocks, you're going to see, let's say you saved your file on the desktop. You're going to have a .cpp file, which is your C++ file. Right? So for example, this thing is automatically saves itself as main.cpp. So every one of your programs has to have this extension. It's .cpp. Okay? Code blocks might try to automatically save as .c, so make sure you change that to cpp. .c is for C, C plus cpp is for C++. So .c is not going to work for this. Okay? These lines are going to mess it up. Okay, so this let's say for example this program main CPP, let's say I had saved it on my desktop. When code blocks, when I hit compile, the next thing it's going to do is it's going to create an object file. Then when I hit in code blocks run, it's going to turn that object file into an executable file. The executable file is the thing that the machine can understand. So we have basically translated all this stuff that I wrote here into machine language, the ones and the zeros, so that it can do something with it. Okay? And let me see. If you really want to see what happens, look at this here, page 8. So all the way on the top is your C++ program. Underneath it is, what we're going to do is we're going to compile that C++ program. See if I can zoom in. No, that won't work. Okay, so there you go, I can zoom in a little. So on the top is your C++ program. What we're doing after that is we're going to compile that thing into an object code. And that's going to be the .o file that's going to be on your desktop if you do it in code blocks. Okay, then what we're going to do is we're going to use something called a linker to convert this object code. We're going to put together the object code that you wrote with other object code which is already part of the language and makes things work. We're going to put them together using a linker, and we're going to create a final executable file. Okay, and that's the thing that can run on your computer. Okay, when you have an executable file, you can just double click it and it will work. For the executable files that you create in this class, if you double click them, it's just going to open up like a little dialog window, the command line window, and as soon as your program is done running, it will automatically close itself. So the best thing to do is just run your programs from code blocks. Just hit the little play button in code blocks so that it makes a new executable file and runs it for you every time. That's the easiest thing. Okay. Some other things. So low-level languages, at the lowest level is a bunch of ones and zeros. If you try to open up an executable file, it will look something like this. It's just a bunch of weird characters. The text editor wouldn't even know how to show it to you the right way. Okay? We humans do not read executable files. They're just for the machine. Okay? If you really wanted to, you can try to figure out how an executable file was written by using a disassembler. So you can grab this code and try to reverse it into one level higher language, and that's called assembly language, right? The assembly language is basically one step above binary. It's really super tedious to write, and here's an example right here of that, right? So basically, there's a whole bunch of instructions that relate to the type of processor that you're using, the kind of computer architecture, and you're telling it things like, oh, move this from processor to RAM, then move this from RAM to processor. It's super tedious, right? So if I was to write something in assembly to give me a hello world message, I would write a wall of text, which is gonna, be prone to me making mistakes and screwing things up. It will be harder to write, it will be harder to figure out how I did things wrong or what I did wrong. And if I wanted to do this in a higher level language, like Python, for example, which I also teach here, I would just do a single line of code like this. Okay? And that's why I recommend taking Python after you take this class, maybe even before this class, but definitely take Python in there to see what a really high level language can do. Very fast, very easy to write. Okay? Unfortunately, C++ is not that high-level language. It's more like a mid-level. Okay? The advantage of C++ is that it's fast. Okay? It also allows you to go and dig deep down into the memory and move things around memory, similarly to how you would do it with assembly. In fact, you can mix assembly code with your C and C++ code in there, if you really, want to inflict yourself pain. But we're not going to go do that at all. Okay? So high-level languages, they're much easier to write. They're much easier to troubleshoot. They're slower to, the programs are a little slower, but they're more portable. They're not tied up to only a specific type of operating system or a specific type of computer architecture. Like if you wrote it in Intel, and it's an assembly program, it's not going to work on any other kind of a processor. If you wrote it on a Windows, it's not going to work on a Mac. That kind of stuff. Okay? Interpreted versus compiled languages. C++ is a compiled language, right? So we're going to compile the thing. There's going to be a final executable, the exe file, which is similar to, like, say, your calculator on Windows, right? You just click the start button, click the calculator, and it opens. You don't need any other program to get that thing working. It just works because you have compiled it to a final executable file. Okay, that's different from how an interpreted language works, right? So if our C++ program creates a final executable file, an interpreted language will kind of stop right here. Okay, so let's say this is a Java program, right? You have a Java program which is very similar looking to C++. You're going to have a compiler. That compiler is going to create an object code, but that is pretty much where it ends. Okay? The linker is actually the virtual machine, like Java virtual machine. Okay? In order for you to run Java on your computer, you need to have Java installed. You can't just run a Java program without having Java. Versus C++, you can just run the executable file. You don't need anything fancy for it. Okay? Another difference is, so this virtual machine that sits here is going to read your object code line by line and execute it line by line, unlike your compiled language, which we created the executable and it just runs all at once. Okay? So that's one. That's one of the differences. Another difference, so the compiled languages are faster, interpreted languages are slower. Okay, compiled languages like C++ are less portable. So if I wrote my executable file here, right, I can't really run it on any other machine. Okay? Or my object code. If I created my object code here, I cannot compile it into something else somewhere else. Versus the interpreted machine, you can put that interpreter on anything you want. If you can program a toaster, if the toaster allows you to do it, you can program it with Java. In fact, if you look at Android, everything is written in Java. Okay, so you can put the Java virtual machine on just about any kind of hardware and program it, so it's more portable, but it's slower. Okay, so we're not going to do an interpreted language. We're going to be doing compiling, so everything is going to be a final exe. Okay, some other terminology. Bugs are just problems with your code. Debugging means fixing those errors, those problems. There's different kinds of bugs. There's syntax errors, which happen before you can run the program. So all these errors that I was showing you, like getting rid of the semicolon, those are syntax errors. And those, despite how cryptic C++ makes them look, are the easiest one to figure out. There's other kinds of errors, which are the runtime errors, which is the program's running, but it doesn't work the way it's supposed to. And that's usually some kind of a logical error. You thought about it, but you didn't think about it all the way or something. Or maybe something happens into the program as you're going in. Maybe you entered a 0 and you're trying to divide by 0. The computer doesn't know how to divide by 0, and it crashes the whole program. Okay? So C++ is not very friendly. It will crash on you left and right. Okay? Unlike other programming languages like Python and Java, they'll detect these errors, and even when it crashes, it'll kind of guide you through what happened. Not this. Okay? All right. So these are the basic terminology. What else do I want to tell you? The basic components of every program are input, output, and then processing, right? Input is something goes into the program, output is something comes out of the program, and then the processing is you do some kind of a thinking. Arithmetic, addition, subtraction, comparing things, repeating things, right? And that is that. Any questions? All right. So, in one of the things in there, in the little comments that I had here, I also had something about an algorithm, right? So what's an algorithm? Let me hide it. Yeah.
Well, you could have another term to use, flowchart, full plan.
There's many fancy ways to describe it, yeah.
Instructions to solve a problem.
Yeah, that's it. It's a recipe, right? We like to have fancy names for things. Algorithm, yeah. There's no equations. You could have a chart or whatever, but I can have a recipe for boiling an egg. You put the water, you heat it up until it boils, and then you put the egg, you wait a couple of minutes, and then you take it off. There you go. That's an algorithm to boil an egg. Not fancy. It's step-by-step instructions to solve a problem. Step 1 usually is what's going to go into the program. Step 2 is where is it going to go into the program. Step 3 is now what I'm going to do with that. And then step 4, how am I going to show some results? Every program is going to be like that, except some of them, they're not even going to have an input. Nothing's going to go into the program. It's just going to happen a bunch of times or something like that. Okay? So if you have a hard time figuring out how to do these programs, write out an algorithm. Tell yourself, okay, I'm going to do this first. I'm going to do this second. I'm going to do this third in your own words, and then you just follow these steps to solve the problem. Okay? So that's it. That's an algorithm. Next.
Would that be in like pseudocode or like?
You could do pseudocode. Yeah, pseudocode is kind of like a code, but it's not real code. But yeah, you could just put it in your own words. First, I'm going to do this. Second, I'm going to do this. And then you can say, okay, well, I'm going to do this more. You can get more specific after you put the general steps first. Okay? And next thing, output. I already showed you output. In C++, output is done with the cout. And one of the first programming assignments that I have for you is to do a whole bunch of output, right? It will look a lot better on your screen. This doesn't show right. Okay, so what you're going to see in there is a bunch of code and a bunch of comments in there explaining you what the code is doing, right? So I would like, well, I ask you to write all the comments in there. They're not optional for this. Okay, at least in the beginning, write all the comments so that you can explain to yourself what every line is doing. Once you have that explanation, you can just go back and look at your old codes to use your code as a reference. I don't expect you to memorize anything here. Midterm and final exam are all open notes. They're even take home, right? So you can use your old assignments as examples. But if your old assignment is just a bunch of code, you're going to look at that thing and you're going to be like, wait, what did I do? What is this supposed to do? How did I do it? I don't know. Write the comments. And that's why in the beginning I ask you to put a bunch of comments in these sample programs that I have. Okay? Once the program runs, it's going to open up a little window on the bottom. You select all that text and you put it at the bottom of the program with the multi-lines, /, asterisk, asterisk, /, and everything in between is the comments. Okay? So that's the output. Now, let me introduce variables, right? So, first of all, what's a variable? And I might have it this. Okay, so in here, I have, let me go to the previous one, and input, okay. So let me just write it up. Okay, so this is an example of output. One thing that I haven't shown you is you can tell this thing to go on multiple lines. Let's say, for example, I wanted to have the hello on one line and I wanted to have the world on a second line. I'll just do \n, right? The \n tells it insert a new line. So when I run my program, there it is. It goes on two separate lines. Okay? I can do this at the end, like that. Right? And if I run it, then it's going to put an extra line right here. I don't have to do it this way. There's another way to do it in C++, and that is you just type end line. Right? And the end L is going to be the same thing as putting a \n. In fact, if I put this and this, now it's going to insert two new lines. Okay? So that's that. Okay, so far you know about one type of information, which is the string, anything in quotes. Okay, I'm going to show you some other types of information. So types of information are also known as data types. Data types, right? What are the different data types? Well, we have char, character, we have int, integer, we have float, we have double, we have string, right? Those are the basic ones. Okay? So, this is the kind of information that can be stored into our program. So, the way we store information into the program is using variables. Okay? What are variables? Variables are words we make up to store info into our program. Okay? So for example, I'm going to go in there, I'm going to say, okay, hold on, there's a string, that's the data type, and it's going to, then the variable is going to be name, or let's call it my name, and I'm going to make it equal to Alex, just like that. Okay? So string is the data type, right? My name is the variable name, and Alex is the information that is stored in the variable. Okay? And there's different types of information that I can store into my variables. Okay? So this was storing an information string. So I'm going to show you the string in here. I'm going to say, all right, I'm going to say cout your name, or let's just label it. My name is equal to, name equals to my name. And by the way, this here doesn't have to match. Let's just call it the name is. All right, my name. And I'm going to put endl at the end, so it just does a new line for me. Okay, and then when I run this thing, the name is Alex. Okay? So this is the little label that I'm showing before the value of the variable. The variable is called my name. Okay, I can change this thing to whatever I want, Alex S with a dot. I run it again. and now it shows a different value for the variable. That's why they're called variables, because they vary, right? They change their values. Okay? Any questions? All right, so that's one type. So I already showed you string. Now let's go in there and show you some other ones. Okay, so another kind of information is integer. So this one was a string. All right, string and integer. So string was anything in quotes. Okay, integer is a whole number. Okay, what's a whole number? Let's go in there and say, okay, age. I have to say int age, and I'm going to make this thing equal to like 10. Okay, and again, int is the data type, right? Age is the variable name, and 10 is the value stored in the variable. Okay? So, I'm going to show you that one too. So, by the way, whole numbers are things like, let's say, I don't know, 1, 3, 100, right? Nothing with a decimal. It does not have a decimal, it's an integer. Okay? And I can show you that variable, same as before, cout, age is age, and del, right? Now run it. There you go, age is 10. Okay? So, one error or common error in the beginning is you defined your variable as, let's say, age here, but maybe you kind of forgot and you want to call it uppercase age here. Right? That's no good. Notice how code blocks automatically highlights this. C line automatically highlights this. Code block will not. Okay? What code blocks will do is will just think it's all good, but when you run the program, you're going to get this kind of a message. Right? What is it saying? It's saying use of undeclared identifier, did you mean age? It's actually smart enough to tell me what I meant. Okay? So what does it mean to declare a variable? So if I say in here, if I say int age right here, I am declare a variable age of the int type. Okay? Then later on I can say, okay, well, age is now equal to 10. What I'm doing now is I am initialize the variable to value 10. Okay? What is the value that is stored in this variable before I do this? Could be any kind of garbage, right? You would think it's a 0 maybe, but no, not necessarily. It could be some crazy big number with a plus or minus in front of it. Okay, why is that? Because age refers to some place in memory, and there may have been already something in that place in memory already, some kind of a huge number. Okay? So declaring, initializing, it's important for you to know what's what in order for you to decipher these error messages. Okay, if you don't know your vocabulary, you're not going to be able to write these programs well. Okay, so in the beginning, it's just you're going to encounter these weird messages, but if you know the terminology, you'll become easier and easier over time to just quickly figure out what the problem is. So anyway, declaring a variable, initializing a variable, and I'm going to go change this thing so that it's right. Now when I run it, it shows fine. Okay? Any questions so far? All right. So you had your integer, you had your string. There's also, I'm going to go with a float, and also double. They're pretty much the same thing, except one is bigger, right? So float is so many digits, double is twice as many. Okay, we're going to look in more detail when we get to that. But they're both decimal numbers. Decimal numbers like 3.14, right? Or 1.234, anything with a decimal after that, after the dot. Okay? So, for example, let's go with float. Let's go, float, weight, right? And I'm going to make this thing equal to, this is declare, right? And what I'm going to do is I'm going to say weight is equal to 123.456, right? This is the initialize, Okay, and the next thing that I'm going to do is, I'm just going to show it like before, cout, the weight is, weight, and L. And then if I run this, and everything is good, there it is. Okay, so that's a float or a decimal number, also known as a double. Okay, so other than that, what else did I tell you? So there's also characters. So there's a whole sentences or a bunch of text in between the double quotes, and you can have char also. Char is single character in between the single quotes. Okay, so it goes like this. Char, I'm going to make this one called letter, and I'm going to make it equal to A, just like that, in single quotes. Okay, and outputting that thing will be the same exact way that I did for all the other data types. Okay, questions? So the data types are the different kinds of information. Bless you. We have integers, we have whole numbers, we have decimal numbers, we have text, we have single characters. Yes, sir?
Does it matter if the variable is named in an uppercase or lowercase?
It does matter. It's because remember how so the question is, does it matter if the variable is named in uppercase and lowercase? As far as, is there a rule to make them all lowercase? No, but usually variables should start with a lowercase, right? I'm just making this L because the lowercase L kind of looks like a 1 and also kind of looks like an uppercase I. All right, so it's just to make it clear. All right, but just keep in mind that if I declare this thing as a letter, right, and I do cout here, the letter is, and I do letter with a lowercase, that's a syntax error, right? It doesn't know what the little letter is because undeclared identifier. So I didn't declare it as lowercase letter, I declared it as uppercase, right? So this is your declare, and so you can declare and initialize on the same line, and I'm just going to change this thing to uppercase letter so it's happy, and if I run this thing, there it is. Okay? All right. So that is the different kinds of information that we store into our program and how we show this information. I'll show you ways to round things when we get to it. For now, I'll just keep it simpler. Okay, so now you know variables, now you know comments, now you know output. The one thing that's left for me to tell you is input, right? And what is input? Input is information that goes into the program. Okay, it's pretty easy. It's just like you would do an output with a cout. There's a reserved word called cin, and that lets you type in something. Okay, so let me just give you an example of what not to do first. So I'm going to say in there, I'm going to say, all right, cin weight, and that's it, right? So first, notice how the program ran before, right? It says process finished with exit code 0. That's basically the thumbs up. It tells you everything finished good, okay? But now when I run the program, it doesn't show that message. Why is that? Because it's actually waiting for me to enter something in here, right? What am I going to enter? I'm going to enter a decimal, 3.14, and then when I hit the enter key, then it ends, okay? And this is an example of what not to do, because when it paused right there and it just did nothing, did you know what to do? Nope. Nobody knows, right? It could be running, could be thinking, it could be waiting for you to enter a number or maybe a string. You don't know what to enter, right? So before you do any kind of an input, right, you want to have a prompt, right? Prompt is tell the user what to enter, right? How are we going to do a prompt, you think? With just the regular output. So cout, I'm going to say, please enter a decimal value for weight, right? You want to be very clear telling the user what they're supposed to enter so that when the program runs, you guide them through the process step by step, right? So this is my prompt. right? The prompt is the text that I'm showing to the user. And then I'm going to have my input. And then let's run the program again. See how it differs from this here. I run it. And now it tells you, okay, please enter a decimal value for weight. Okay, I know what I'm supposed to do, 3.14. And then nothing, again. So a good thing to do is show what the user entered, right? Because sometimes maybe you declare this thing to be an integer and you accidentally told them to enter decimal. And you're going to enter a decimal into an integer and it's going to lose all the decimal values automatically. Okay? And I'll show you some examples of that later. Okay? And so, for example, I want to show cout the value entered was, and weight, and L. Right? Run it again. And 3.14. The value entered was 3.14. Okay? So the basic thing of any program is something goes into the program, that's your input. Then you're going to show, right? That's your output is show some information. And then maybe you're going to do some math with it, right? Maybe you want to convert the weight from pounds to kilograms or something, right? So let's say I'm going to please enter a decimal value. Let's say, please, just get rid of the please to shorten this thing. So enter kilogram value for weight, and I'm going to put like a little decimal, right? So that they know that it's a decimal, right? So what's the processing business? Okay, well the processing is this. So processing for now is just, let's say, arithmetic. Okay, if I could spell it, right? Arithmetic, like addition, subtraction, multiplication, division, right? Those are the basic things. You can also do powers and all kinds of other things, but we'll leave it at that. How does the computer know to do these kind of things? It's built into the processor itself. Okay, the processor knows how to do these things, and we just take advantage of that. Later on, we're going to realize that it can also do things like comparing things to each other. It can check to see if this thing is equal to this thing, or if this is bigger than this. That stuff is built into the processor, into the arithmetic logic unit, the ALU, okay, which is the part of the CPU. All right, so the processing I'm going to do here is I'm going to make up a new variable. Not that I have to, but I will. I'm going to say, all right, float, and I'm going to call it weight pounds, right? And I'm going to say weight pounds is equal to my weight times 2.2. There you go. Okay? So I'm going to go in there. That's the processing. And then I'm going to show the output. Output is the results, the final results. Final results, right, is cout the weight in pounds is, and you do weight pounds, right, and then run this again. And now it's asking me for kilograms. All right, let's do 150. So 150 is 330 pounds. That's not right. Oh, that's right. 150 kilograms is a 330. All right. Okay. Any questions? Input, output, processing, right? Or input, processing, output. Those are the steps of every program. Okay. So let's go back to the class page. All right. So I did that. And I am just going to go through the different assignments that I have posted for today, because next time we're going to be covering selection. So the class moves pretty quick. All right? So make sure you keep up with these assignments. There's going to be like 60, 70 of them or something in the semester. So if you don't keep up, you're going to fall behind, and it's really not going to be fun for you. Okay? Because you're going to be just lost. You might as not well come to class. Okay? So there's a couple of extra credits in there. Read these, watch these, answer them if you like. They're not going to count against you. I'm just going to go through these programs 1 through 6, show you what you're supposed to do, give you some hints on them, so that you hopefully can complete them by Thursday, and then on Thursday we'll go on and do selection. Okay, so first assignment is you're going to type up the sample program and display 1.8 in the PowerPoint. Which PowerPoint? This one right here, the Savage one, right? It tells you PowerPoint, so download it, look at this thing. Hopefully it opens up right here. And we're going to go to page 18. Or it's before 18. Where's this thing? No, it's display 1.8. Where are the displays? I think they're all the way at the end. Wait for it. Come on. 1 second. Maybe I have the PowerPoint open already. No. Oh, there you go. These are the displays. And again, the PowerPoints are going to go into maybe a little bit more detail than what I covered to tell you how variables are stored into locate in memory. And one of these displays is display 1.8, where you have a sample program. You just type up the sample program, get it to run. It should run like the thing on the bottom. Make sure you copy paste this at the bottom of your code. Make sure you have comments at the top of your code also. And that one's done. Okay? If it doesn't work, if you get stuck on something, just send me an email. Tell me, hey, look, here's the program, here's the error message, help. Okay? So that's that. The other thing is P2, print CS. So in here, what I have is write a program that prints out CS in large block letters inside of a border of asterisk followed by 2 blank lines like what you see below, right? What do you got to do for this? Your little hint that I'm going to give you is, so this is hint for P2. Hint, let's do it, P2 hint. P2 hint is, the easiest thing to do is just grab all this stuff here. I'm just going to grab some of it. I'm going to get up to here, right? There, right? And maybe a little more, there. Okay, and then I'm just going to paste it in there because I'm lazy. And then I'm going to do cout, and I'm going to put, oops, I'm going to put quotes at the end, semicolon, and I'm going to do a \n to indicate, telling it, to tell it, show a new line after this one, right? And then I'm going to just do this for every other line after that. So I'll do cout, quote, quote, I can do just a \, for this one, and then I'm just going to copy this now, get extra lazy, paste this here, 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 and then close every one of these lines with this. Whoops, damn it, where did the \? Go? Copy this. There we go. Alright, so when I run this thing, you're going to see that it kind of looks like, oh, I messed this up too. I'll just delete these couple of lines here. Yeah, that was the C. I kind of moved things around. Anyway, so just you do this, right? So you do a cout with quotes in front of each of these, and you do \n at the end, and then when you run the program, and of course it's going to ask me for all these other things that I asked, it's going to show CS with big letters made up of little letters, right? That's your output. Then you copy this thing, copy it, put it at the bottom of your code for that program, right? And that's your program. You submit it, make sure the program name is the correct one. That was P2, right? Put the date, description. You can copy the description from the program, right? The description will be, you can just go in there, grab this whole thing here, right? Copy it, and you can even put it as a multi-line comment like this, right? Paste all that stuff in there. So you know what the program is supposed to do, okay? So I'll just get rid of it for now. Okay, this stuff gets inserted automatically by CLine. CodeBlocks is not going to do that. Okay, so that's the second one. Third one, input-output processing. Write a program that reads into integers and then outputs both their sum and their product. You may modify the program in display 1.8. 1.8 was the first one you did, but here I'll give you another example. So I'm going to go in there and I'm going to do P3 hint now. P3 hint, All right, so it asks you to do two numbers. Find the sum and the product of two numbers. I'm going to give you two, or does it say what? Two integers, right? So they're supposed to be integers. I'm going to say int a, whoops, a, b. You can declare both of them on the same line, right? Declare both on the same line, and I'm going to tell the user cout, please enter num1, right? And I'm going to do cin a. I'm going to copy this line, these two lines, paste them. This is going to be num2, b, right? And let's say I'm going to show you cout, or let's do int div is equal to a divided by b, something like that. And then I can show you cout a divided by b equals div and L. Okay, so you can do this. You can put multiples of these on the same line. You can just connect them with the less than. Okay, and L. Right, let me run this. So whatever, please enter num1, 4, num2 is 2. So 4 divided by 2 is 2. Okay, use this example to do the sum and the product. Okay, so that's your P3 hint. Now let's go to the next one. P4. Print C using a letter. There's a video in there to show you how to do that. Well, why not? I'll show you how to do it anyway. So this is similar to that first one we did with the two letters with the CS, right? But this time this I don't want it to show with whatever letters that I chose here, but whatever letter the user enters. So if the user enters X, this is going to be we're going to make a CS out of the letter X. Okay? So this is P4 hint. All right, P4 hint. I'm just going to paste that whole thing again. Oops. Is that what I did? Yeah, it messes it up on purpose. Okay? One more time. Tab. What is it supposed to look like even? A little space. There you go. That's supposed to be a C, all right? Or the beginning of a C. Let's call it that. So what I'm going to do is, I'm going to get rid of this. Well, I'll leave it there. So cout for this, there. I'm going to shorten this a little bit. Okay. We're going to do a \n inside to save space. I could also do the and L. And here I'm going to do a cout, this, quote, \n. And I'm going to do the same thing for all these other lines. So here, and I'm going to close every line with the same thing. Okay? So this should show me like a little C or whatever, but it will be made up of the letters X. Okay? That's not what I want. And what I want is, I want the user to enter something. So I'll tell the user cout, enter a letter. Okay? And I'm going to do cin. I'm just going to do capital L. Right? And it's not going to like that because I haven't declared L yet. I'm going to go in there. Let me declare it. So this is going to be a char L. I'm not going to put any values in it. So declare. And the initial value is going to come from the user. Right? And then what I got to do is, I just have to replace these here with the L. But what I have to do is, it's not going to be in quotes anymore, all of it. So what I have to do is I have to close my quotes here, less than, right? Less than after, less than here, less than there. These little extra spaces, I'm going to put quotes around them, right? Because there was like a little space here before in between the letters. So I'm going to put quotes there, all right? And then less than there, okay? And now it's complaining, and here too, Okay, now it's complaining because it doesn't know what X is. That's fine. I'm going to use L, right, to replace the X. So that one is an L. I need to do another one here, less than, less than. All right, so I'm putting the variable. I can put a little space in there if I want to. That's not going to change anything. Space in there so you can see it. And this is the last one. All right, L. Okay, I'm going to do the same for this here. I'm going to close, first of all, this space right here that's between the letters. Let's just do this. I'm going to say less than, less than, less than, less than. I'm going to throw in a quote in there and quote in there. I'm going to do another quote in there, less than, less than. And this one, last one, less than quote. Okay, I'm going to replace this with an L again, this with an L again. All right, this one here, this last one's easy. I just got to put the quotes here, less than, change this to an L, throw the quotes for the backslash n, and then another less than there. So I guess you have to do one before and after. One here, one there, throw the quotes, throw an L in there. Okay? So now when I run this thing, even though it looks weird, it should kind of look like a C. All right, but made up of whatever letter the user enters. So I'm going to go in there, whatever, enter a letter. I'm going to put the letter O, capital O, hit it, and it will make up the letter C out of a little O letter, the big O letters. Okay? Make sense? Okay, that's your P4 hint. Next one, P5. Write a program that draws a picture using cout and a simple text. There's an example in here. If you can't think of anything to draw, you can just copy my masterpiece. I'm not an artist, okay? You should be happy that I could do a triangle, right? Right? So if you can change it to a box or something else, you got that one right, okay? So don't think about doing graphics and stuff like that. That's not what we're doing. Just basic couts, okay? And it will look like this. Copy that, paste it at the bottom of your code, just like any other program, and that's done. So no hints necessary for this, because here it is. Your hint for that. Next one, P6. 2 output programs. This one's pretty easy. Write a program that shows as many different words as you can think that can be formed using the letters crate. So rat, rate. Whatever, right? Just make up some words, show them on the screen. Each word should appear on a separate line. So you do a cout, \n, another word, \n. Do a couple just to get practice with output. That's that. There's a couple more programs in there. Write a program that draws a picture of a spaceship using cout. I couldn't draw a spaceship to save my life. So if it kind of looks like a spaceship or whatever, don't worry about it. I'm happy with that. Or you can write a program that shows the longest palindrome you know. You can Google it, right? What's a palindrome? It's a word that can be spelled the same way back and forward. Okay? And then later on, maybe we can write programs to detect if a word is a palindrome or not. But for now, just make up some palindrome, show it, and that's it. Okay? So just basic output. But you got to do 2 programs for this. You can include, but both of these programming assignments, put them in a single program. Okay, so show how many different words you can make up with the letters in crate, and then show the palindrome in a single program file called P6. Any questions? Okay, so we still have about half an hour. I suggest you fire up code blocks and start working through these. That way, if you encounter any problems, it's easier for me to help you in person than it is to do it online. But if you want to take off, you're welcome to do that. Just send me your questions, email me your questions, and I'll answer them. Usually within 24 hours on weekdays, 48 hours on the weekend. I'll try to do it even faster than that, but stuff happens. So what I'm going to do is I am going to go and upload the lecture right here on the bottom. Next to the lecture, I'm also going to put the video. That way you have the transcript of everything I wrote and the video next to it. So that should do the job. And that's all I have for today. Thanks for taking the class. Thanks for coming. Just ask me questions if you need help with anything. Just don't worry about it, okay? So that's that.
The general question.
Yes.
So the code blocks or the C line, it really doesn't matter which one you use.
It doesn't matter, but code blocks, I would recommend start with code blocks because you will learn the syntax a little better. C-Lion is kind of like, I mean, code blocks and C-Lion is like, would you write your paper in Notepad or would you write it in Word? Okay, Notepad, it might seem kind of weird, but you're going to learn, you'll be forced to learn the syntax. Also, code blocks, I mean, C-Lion, you're going to have to create a whole project to get this thing going. You're going to have to rename each of these files. So we'll go in there and we'll make a, this is my file in there. There's like a weird structure. It will always create the file main CPP. If you create some other file name and you try and run that thing, you're going to have to go in there and change the CMake list, which is like beyond the scope of what I want to teach you. Versus code blocks, you just have a C++ program, you open it, you run it without anything else. But either way is fine, whatever you want. Just make sure that if you're saving these programs, save them with the correct program name. Don't give me a whole bunch of main.cpps. Name it P1, P2, P3, P4. If you can do that, you can use anything you want. You can use something else other than C-Lion too.
What's the industry standard right now?
This is really good, but if you're going to be doing stuff on Windows, usually it's Visual Studio, Microsoft Visual Studio. That's the industry standard. If you're going to be doing stuff on a Mac, Xcode is the go-to for that. But you can use C-Lion on any operating system. That's why I kind of like it, because it doesn't matter on what operating system you're on. You can do this. You can also, yeah, I'll just leave it at that.
Thank you.
Yep. Any other questions? Okay,
So
yeah.
Is this everything that we went just today? Is there going to be a summary of a video, or is there notes?
Both. I'll post the notes of everything. So all this stuff here is going to be posted, and I'm going to show you. I'm going to put the video. I just recorded all the stuff that I said. I'll put that too. Okay. Alrighty. So let me stop this thing. If I can figure it out, I have to unplug this first.